We are going to be talking about exponents and powers. All right, so let's identify some of the pieces and parts here. What do we call the big three? Anybody know what this is called right here? No? Okay, it's called the base. Some people refer to it as the base number. That's the base of an exponent. The 4. We know what the 4 is? Well, the exponent, right? Bless you. All right. Pretty basic. Now, what do we call all of this together? The 3 and the 4. That has a term. Tooth term, it's called the power. That's what that is called. Or oh, that can't write. Or exponent form. Okay, you got to know the pieces and parts of the powers. The big number is the 3. That is called your base number. The exponent always goes to the upper right. Does not go to the left. It always is in the upper right. So far, so good? Okay, you know the pieces and parts? All right. Let's talk about what they do then. All right. Well, actually, let's talk about words here first. Oops. We've already talked about this briefly. How would you read? Come on. How would you read that number? How would you read that exponential form right there? Okay, Han. All right, 3 to the second power, or most people would just say 3 squared. Okay, and he is right. You could say 3 to the second power. That is fine too. Nothing wrong with that. Perfectly acceptable. Okay. How do we do this? How do we read this? Okay, that would be 3 cubed. Okay, how do we read this? How do we read the one in yellow? Stumper. Okay, on. 3. You are correct, sir. Very good. Okay, listen carefully. When the exponent is 2, we use the word squared. When the exponent is 3, we use the word cubed. After that number, there is no other special number. You hear me? Okay, you would simply say the base number, in this case, 3 to the 4th power. Okay, if it was to the 12th power, what would you say? 3 to the 12th power, right. There are no other special words other than squared or cubed. Okay, this would be 3 to the 12th power. Okay, everybody good with that? Now, you can say what Kahan said. You can say 3 to the 2nd power or 3 to the 3rd power. That's acceptable too. But you will find out that most people use the word squared and cubed. It's just a shortcut for the 2 and the 3. Everybody good so far? Okay. All right. What if we have something that looks like this? Oops. All right. We have 4 times 4 times 4 times 4 times 4. Well, hang on. My first question, I know what you're going to ask. My first question is, what form is that in? That form right there has a name to it. What do we call that? Grayson, do you know? Okay, very good, sir. That is called expanded form. That is correct. That is called expanded form. You've expanded it. You've made it bigger. That's what expand means, right? All right. If we were to put this into power terms or exponential form terms, what does that look like, Maddie? All right. Very good. 4 to the power of 5. Why the 4? Because that's the base number that is appearing. Why the 5? Because you have 5 4s. That's exactly right. Okay. So far, so good. Okay. That's going to be no different if we give you something that looks like this. If we give you it in exponential or power form and ask you to write it in expanded form, what does that look like? Masa? 12 times 12 times 12. Notice I'm using the raised dot, not the X. Okay. Can you use the X? Yeah, but the raised dot's better. Now, you could also express it like this. This is fine too. There's nothing wrong with that. Okay, and you could put parentheses around the first one too. It doesn't matter. Why is that okay? What lesson did you learn that in? Not one. What were your properties? Lesson 1-3, right? Multiplication property of, or I'm sorry, the commutative property of multiplication. Okay, doesn't matter. So far, so good. Everybody okay with that? Okay. Let's talk about this. We've briefly mentioned this. Let's talk about perfect squares. If I write the number 64 and the next one is 20, does anybody know how you can tell whether one of those, both of those, or none of those is a perfect square? Tyler? Number 2 is. Why is number 2? Because you can divide it by 4. Okay. Anybody else? Michael? If it ends in a 0 or 5, it's a perfect square. Is that what you're telling me? Okay. Anybody else? Nobody else has any? You can guess. It's okay. Nobody else? $64 because it can be divided by. Can be divided by what? Can be divided by 4. Okay. Kahan. I didn't hear you, buddy. So they can be divided by 4. So we're making a rule that says something that is divided by 4 can be a perfect square. Because I'm assuming that you're thinking because a square has 4 sides. Is that my thinking is correct? Okay. Michael. Maybe it has to be an even number. Okay. Are we good? All right, those are your guesses? Would you like to know the results? You're all wrong. Mm-mm. Perfect square. Might want to pay attention. Remember, we put up a perfect square that looked like this, yes? And do you recall me putting 2 numbers, but what did I say if there was 1 number? What did that mean? They're all the same side. Very good. Nice job, Emma. They're all the same side. So to find perfect squares, children, it's really simple. You have to know your math facts and multiplication. That's how you find a perfect square. In 64's case, isn't that the power? 8 squared? What does that look like in expanded form? 8 times 8. Winner, winner, chicken dinner. In 20's case, you have 2 times 10, 4 times 5, 1 times 20. Uh-oh. Are any of the factors the same? 20 is not a perfect square. 64 is, because 8 times 8 gives me 64. You have to have 2 factors that are the same to give you a perfect square. Okay? Now, to somebody's point a minute ago, is 25 a perfect square? Once again, you got to know your facts. The reason I put that up there is somebody said, oh, they're all evens. Well, last time I checked, 5 times 5 gives me 25. That means if I draw a square and I do this, all sides are 5, that's a perfect square. Don't think odd or even, think your math facts for a perfect square. Okay? Everybody okay with the perfect square? Now, these questions, let me go backwards here. These questions, they're going to ask you, they're just going to put up, hey, is 64 a perfect square? And you know what your response is? It's either yes or no. That's correct. Okay, it's either yes or no. Yes, it is a perfect square. No, it's not a perfect square. Okay. Perfect squares are pretty easy. All right, we're okay with the expanded form. Oh, actually, let's do that. I'm not sure that we did that good enough. Okay, so let's go the opposite way. Right? Or I think we did. So if we have 5 to the third power, they want you to write that in expanded form. You get this, correct? You know what will be the well, not the most common, but you know what the mistake will be made? Yep, you're going to do 5 times 3 and get 15. That's not right. All right. So let's talk about what this answer is. That answer in the red has a word form. Numbers that are just written as answers, all of them are called, anybody know? Starts with an S. Not simplest. That's a good guess, though. Standard form. Okay. Most of your answers on your test were in standard form. Okay. We don't normally say that, but you have to recognize it. You got to know what it is. A number just written as an answer, okay, is standard form. All right. Everybody good with perfect squares, expanded form, powers, exponents? Everybody good? Are you sure? Okay, you can always go back and watch me teach. All right, moving on. Next. Maybe. Order of operations. All right, tell me what you know. I know you know this. Mason? Sorry. Cohen, sorry. I have no idea what he said. All right. What's that saying? All right. Please excuse my dear Aunt Sally. Bless you. All right. Parentheses. Exponent. Multiplication. Division. Addition and subtraction. Oops. Now, here's the crazy thing about the order of operations. I'll give you a minute to write that down. Here's the crazy thing in my world, in the math world, not just my world, about the order of operations. When in the course of the math world do they give you the answer before you start working a problem? Never, right? Never. This is just the opposite. Children, they're telling you how to solve the problem. They're giving you the answer, the algorithm before you start the problem. If you are disciplined enough to ask yourself these simple 6 questions every single time, over and over again, there's no way that you can miss a problem. They're telling you what to do. Are there parentheses? If you answer no, you move down to exponents. Is there an exponent? No. Then I move down to multiplication. And then if you answer yes, then you solve it. Right? And then you move on to division. Is there division? No. Is there subtract or is there addition? Yes. Solve that. Is there subtraction? Yes. Solve that. And then you will get your answer. I just recognized something. What did I write there? I meant the right exponent. All right, everybody good? Do you know the 2 exceptions to the rule? Come on, you told me you were well versed in this. There's 2 exceptions. If I could only write on this thing, that'd be dangerous. Exceptions. There's 2 exceptions. That says exceptions. Sorry. My smart board's acting up. 2 exceptions. Anybody? Emma? Okay, yes, define the beginning of it. You're absolutely right. And this is what I always say. How do we read here in America? Left to right. That is correct. Nice job. Okay, so when you only have, Emma's exactly right. When you only have multiplication or division, addition or subtraction left, you solve going left to right. That sometimes gets you as well. Because what's happened is you'll get so well versed in, looking for the parentheses and exponents and doing them in order that they'll throw one in there that just has multiplication, division, and subtraction, or an addition. And then all of a sudden you're like, oh my gosh, what do I do? What's the other exception? There's one other one. When there is an exponent inside of parentheses, that's Parentheses. Those are the 2 exceptions to the rule. Other than those 2, every single problem is solved. Please excuse my dear Aunt Sal. Going forward throughout the class, you have to keep those forefront when solving math problems. That is never going to go away. That's how you solve every single math problem. So far, so good? Nathan? Going. Sorry. Solving going left to right. Yep. Unfortunately, my stylist is not the best. Yeah, if you have any questions, please let me know. I'd be happy to. Because I can't type. My keyboard's on the other side. It's a good suggestion, though, but unfortunately, the keyboard's underneath. All right, everybody good? Are you sure? Okay. Let's try a few. All right, we'll start off easy, I hope. All right, what if we do this? Oops. Now I'm going to show you what is a recommendation. Just a recommendation. I still do it today. Okay, so ask yourself, any parentheses? No. Any exponents? No. Any multiplication? No. Any division? Okay, here's what I recommend doing. Whatever problem that I am working on, I underline the numbers, the two numbers, and the division sign. And I'll tell you why. Okay, this is a pretty simple problem. I understand that, but you're going to find out here they're going to get longer and you're going to have multiple steps. When you underline the operation that you're doing, it's so much easier to go back and correct and see which operation you didn't do correctly. If you don't underline anything and you just have a bunch of numbers come down, then you got to go back and you got to try to figure out what you did and where you went wrong. Just a little bit more confusing. What's 18 divided by 3? 6. So underneath that, I bring that down. And I bring down everything else I didn't use in the problem. So let's examine this. So now I have two problems, yes? The first one is no longer my problem. I solved it. That's no longer my problem. Now my new problem is 21 minus 6, which is 15. Okay, you're rewriting the problem. Does that make sense? You're creating another problem when you... Okay. Everybody good? All right. How about this? Uh-oh. 9 plus 3 in parentheses divided by 6 times 2. Oh, boy. Do we have parentheses? We need to do those first then. Now, when you have parentheses and you solve inside the parentheses, guess what happens to the parentheses? They go away. Listen to what I just said, though. When you completely solve inside the parentheses, then they go away. So in this case, if we get 12, they go away. Listen, you're going to get into trouble if you try to do too many operations at once. Okay, you are now creating another problem. Okay, that was one. Now we're on number 2. What do we do next? Michael, the exponent. We have an exponent. Parentheses are gone. We have an exponent. Number 3, 12 divided by 6. 2 cubed is what? 8, not 6. It is 8, not 6. Now, here comes the problem. What do we got next? What do you want to do next? Talk to me. How many of you want to do 6 times 8? How many of you want to do something else? Oh. How many of you don't know? We have no honest people in here. Oh, okay. All right, we got one honest people. Okay, what do we want to do next, Grant? And why? Okay, Grant says he wants to take 12 and divide it by 6. Why, Grant? Because you have an exception to the rule. You have multiplication and division only left. See, now this is tough. Why is this tough? Because we're on step number 3 and that rule comes into play. See how you got to be on top of your game? Yeah. Because if you take 12 divided by 24, does anybody know? I'm sorry, 12 divided by 48, you know what you're going to get? 0.4. If you come out with a decimal right now, guess what? You're wrong. These are whole numbers. Okay, so we do this first. 2 times 8. Okay, that's a 5-stepper. And in step 3, we had an exception to the rule. Listen, I'm not going to tell you, that's hard. Right? You're solving your problem. That's what I just said. Oh, parentheses, exponents. I get down to number 3. You've got to recognize that that's an exception to the rule. Try another one. Nine squared minus parentheses 6 squared times 2 minus 1. Ooh, baby. What do we want to do first? Cohen. Yes. That is the exception to the rule. Okay, now we write down everything we're not going to use. Are the parentheses going to go away here? No, not initially. You can't do two things at once. 36 times 2. We solve the exponent first. The parentheses are not going to go away because we are not taking 36 times 2 immediately. Okay, step 3. What are we going to do next? I want to pay attention, Oliver. What are we doing next? Zach. Okay, 36 times 2 is 72. What are we going to do next? Okay, we're going to do the exponent next, right? 81 minus 72 minus 1. How are we going to solve step 4? We're going left to right. That is correct. 81 minus 72 is 9 minus 1. We get 8. That's got 6 steps to it. Okay. So far, so good. Yes or no? One more? Okay. I'll let you do this one on your own. How's that? All right, here we go. Okay, that's 55 divided by parentheses 4 plus 1 times 3 minus 3 cubed. I'll give you a minute to solve that. Bless you. Are we good? No? What'd you get?
6.
I got 6. I got 24. What else? Keep throwing them out. 6, 24. What else? What'd you get? 50? 50. What else? Children, can you yell out answers? Everybody has one of those? What do you got? 6. Okay. All right, here we go. Let's solve it. What do we do first? We do this, right? Okay, so we get 55 divided by 5 times 3 minus 3 squared. Oh, 3 cubed. Sorry. Okay. We get 55 divided by 5 times 3 minus 27. Okay, so that's correct. Some of you put a 2 rather than a 3. You got to be careful. What do we do next? Division. You have multiplication, addition, subtraction, all in the same. You go left to right. 55 divided by 5. 11 times 3 minus 27. 33 minus 27 gives us 6. Very good. Nice job. You got to be careful there. All right, any questions? Are we feeling good? Feeling comfortable? Okay, listen, go back and watch the videos. Okay, if you need help solving these. Okay. On, or I should say not on, in Polaris. Okay, I believe we are in week 5. We are in Wednesday's folder. Okay, I believe there are 3 pieces of paper. Okay, you're going to do all of those tonight for homework. Trust me, you can get done with those in essay. Okay, combination of powers, exponents, and a little bit of order operation.